Hi, let's continue the distributed database system concept lesson. We will continue with concurrency control and recovery techniques, query processing, and categorization of DDBMSs. Although DDMS offered advantages, there are also some problems specific to distributed DBMS environment as shown in the slide. Multiple copies of the data items, failure of individual sites, failure of communication links, distributed commit, distributed deadlock. In distributed concurrency control based on a distinguished copy of a data item, particular copy of each data item designated as distinguished copy. Locks are associated with the distinguished copy. Primary site technique. All distinguished copies kept at the same site. Primary site with backup site. Locking information maintained at both sites. Primary copy method. Distributes the load of lock coordination among various sites. In distributed concurrency control based on voting method, there is no distinguished copy. Lock requests sent to all sites that contain a copy. Each copy maintains its own lock. If transaction that requests a lock is granted that lock by a majority of the copies, it holds the lock on all copies. Timeout period applies. Results in higher message traffic among sites. In distributed system, it is difficult to determine whether a site is down without exchanging numerous messages with other sites. In distributed database and transaction systems, a distributed commit protocol is required to ensure that the effects of a distributed transaction are atomic. That is, either all the effects of the transaction persist or none persist, whether or not failures occur. When a transaction is updating data at several sites, it cannot commit until certain its effect on every site cannot be lost. Two-phase commit protocol often used to ensure correctness. Global Transaction Manager supports distributed transactions. Role temporarily assumed by site at which transaction originated. Coordinates execution with transaction managers at multiple sites. Passes database operations and associated information to the concurrency controller. Controller responsible for acquisition and release of locks. Two-phase commit. This protocol requires a coordinator. The client contacts the coordinator and proposes a value. The coordinator then tries to establish the consensus among a set of processes, A.K. participants, in two phases, hence the name. Coordinator maintains information needed for recovery. In addition to local recovery managers, three-phase protocol is an extension of two-phase commit wherein the commit phase is split into two phases. Prepare to commit phase communicates result of the vote phase. Commit subphase same as two-phase commit counterpart. Stages of a distributed database query. Query mapping refers to global conceptual schema. Localization maps the distributed query to separate queries on individual fragments. Global query optimization strategy selected from list of candidates. Local query optimization common to all sites in the DDB. Data transfer costs of distributed query processing is a cost of transferring intermediate and final result files. Optimization criterion, reducing amount of data transfer. Distributed query processing using semi-join reduces the number of tuples in a relation before transferring it to another site. Send the joining column of one relation R to one site where the other relation S is located. Join attributes and result attributes shipped back to original site. Efficient solution to minimizing data transfer. Query and update decomposition. User can specify a query as if the DBMS were centralized. If full distribution, fragmentation, and replication transparency are supported. Query decomposition module breaks up a query into subqueries that can be executed at the individual sites. Strategy for combining results must be generated. Catalog stores attribute list and/or guard condition. There are two factors that influence types of DDBMSs. Degree of homogeneity of DDBMS software. Homogeneous. Heterogeneous. Degree of local autonomy. No local autonomy. Multi-database system has full local autonomy. A federated database system consists of component DBS that are autonomous yet participate in a federation to allow partial and controlled sharing of their data. The slide shows the difference between the homogeneous and heterogeneous types of distributed database management system, DDBMS. This slide shows the classification of distributed databases based on three dimensions: distribution, heterogeneity, and autonomy. There are some issues regarding federated database management systems. Differences in data models. Differences in constraints. Differences in query languages. Semantic heterogeneity. Differences in meaning, interpretation, and intended use of the same or related data. Design autonomy allows definition of the following parameters: the universe of discourse from which the data is drawn, representation and naming, understanding, meaning, and subjective interpretation of data, transaction and policy constraints, derivation of summaries. Communication autonomy. Decide whether to communicate with another component DBS. Execution autonomy. Execute local operations without interference from external operations by other component DBSs. Ability to decide order of execution. Association autonomy. Decide whether and how much to share its functionality and resources. Computing is a computation type in which multiple processors execute multiple tasks simultaneously. Distributed computing is a computation type in which networked computers communicate and coordinate the work through message passing to achieve a common goal. The main difference between parallel and distributed computing is that parallel computing allows multiple processors to execute tasks simultaneously, while distributed computing divides a single task between multiple computers to achieve a common goal. It shows some different database system architectures. A. Shared nothing architecture. B. A networked architecture with a centralized database at one of the sites. C. A truly distributed database architecture. The diagram in the slide is the schema architecture of distributed databases. This architecture generally has 4 levels of schemas. Global conceptual schema depicts the global logical view of data. Local conceptual schema depicts logical data organization at each site. Local internal schema depicts physical data organization at each site. External schema depicts user view of data. 3 types of distributed catalog management: centralized catalogs, fully replicated catalogs, and partially replicated catalogs. In centralized catalogs, entire catalog is stored at one single site. It is easy to implement. In fully replicated catalogs, the identical copies of the complete catalog are present at each site. Results in faster reads. In partially replicated catalogs, each site maintains complete catalog information on data stored locally at that site. In this lesson, we have learned distributed database concept, distribution transparency, fragmentation transparency, replication transparency, design issues, horizontal and vertical fragmentation, concurrency control and recovery techniques, query processing, ANS categorization of DDBMSs.